Welcome to today's webcast. This call is being recorded. And now to begin the program, I'd like to introduce Chris Flack.
Hey, James. Thank you so much, and welcome everybody in our audience to today's webcast, Protecting Virtual Machines with Data Replication, sponsored by StarWind. I'm Chris Flack with Redbased Magazine. I'm here to be your host for today's event. Thank you all for joining today's presentation. We greatly appreciate that. Now, just a few quick reminders before we begin today's presentation and introduce our speakers. We will have a Q&A at the end of today's presentation. However, we do encourage you at any time during today's presentation to enter your question via the Ask a Question box appearing on the left-hand side of your console. And hopefully, if time permits, we'll get to everybody's questions and get out some answers. Also, today's webcast is being recorded and archived for future viewing and listening purposes. And we'll send you a link to the email you registered with within 24 to 48 hours after today's webcast. Please feel free to share that link with coworkers, colleagues, and friends, anybody who may be interested on today's topic. Today, we're going to be joined by three really great presenters. I've had a chance to work with all of them, actually. They're really great guys. Later on today, in today's webcast, you're going to hear from Max Kolomeitsev. He works with StarWind software. He's going to be here to explain what StarWind software has to offer. Also, a little bit later on, you're going to hear from Matt Price. He is from Veeam. He's going to be here to talk about a little bit what Veeam has to offer. First up today, though, is Chris Evans. He's from LinkedIn Blue, Ltd. He's going to be the first speaker in today's webcast. All three guys are years of IT experience in the field, are filled with tons of information, so everybody out there is going to learn a great bit today. But without further ado, let me hand things over to Chris so he can get started with what you'll learn today and the overall presentation. So, Chris, why don't you take the floor?
Thanks, Chris, and good morning to everyone. So, yes, as Chris has just said, let's start by talking about what we intend to learn today within this webinar. So, the first thing is we're here to talk about data replication, and we need to discuss why we think we need to do data replication in the first place. We'll define what data replication means, and we'll talk about the different modes of operation of data replication. And then we'll move on to talk about array-based replication and how it might not be the best solution for virtualized environments. We'll then talk about volume-based compared to VM-based replication tools and the differences between the two and the benefits and the disadvantages. And from that point, I'll hand over to the Veeam and the StarWind team, and they'll take you through their technology to explain specifically how their products actually relate to data replication. So let's move on. So we'll just flip past the, the presentation slide. I'll give you a little bit about myself. Chris was very kind to introduce me. I'm an independent consultant with a company called LinkedIn Blue. I'm a blogger as well. I do a little bit of analysis and work mainly as a consultant. And you can catch me online on Twitter or through the website Architecting IT. So let's talk initially, why do we need to replicate data? Let's talk about that subject to begin with. Well, clearly for a lot of people, a lot of organizations, data and their IT systems are becoming increasingly important to the extent that the IT systems are actually the major part of their business. And many organizations can't run today without actually having IT systems. The reason is we use our IT systems, for instance, for customer-facing websites to allow customers to purchase things from companies, but also internally, those systems are used for things like manufacturing, marketing, sales, and of course, they're also used for things as simple as things like email and VDI. And of course, we all know how important email can be because a lot of business traffic goes across the email systems. So it's true to say that businesses can afford very little or potentially no downtime or service outages. So keeping things up and running is incredibly important. Now, obviously, there are lots of things that can affect your ability to keep your systems running. And some of the more obvious ones would be things like fire or power failure in your data center. But obviously, there are some that, depending on where you are in the world, become even more important, and you see issues with floods and earthquakes in certain areas. Now, those tend to be the most obvious issues, but you know there are other things that can affect your ability to run your operation as well. You might find that you have the inability to access your facilities. For some reason, you can't get into your data center or you can't get into your office. And that can happen for the obvious things of fire and flood. But obviously, you know, there could be more damaging issues around chemical spills or other things like that. We have to bear in mind that we may experience things like criminal or malicious damage. We know that there are hackers out there trying to steal data and damage systems all the time. But the other things that we see in that sort of area are the idea of disgruntled employees who clearly feel like there's an issue with how they've been treated within an organization, and they choose to damage systems as they leave. And that happens, thankfully, not too often, but it does happen. And finally, one other thing to bear in mind is that, of course, we could have system or application failure due to things like software bugs or failed upgrades, or other reasons why we have data corruption. Now, to give you an example of how important that is, there are some brief statistics there which you can read. But basically, 30% of businesses that have a major fire go out of business within a year, and 70% of those businesses fail within 5 years, which is an amazing statistic that gives us an idea as to how important it is to make sure we've got a backup of our data. So let's talk about what data replication actually means then. So when we say replication, we're actually talking about the process of copying data from one system to another in order to give us and provide us business continuity and to be able to get out of a disaster scenario and basically to provide disaster recovery. So replication gives us, amongst other things, 3 main features. It gives us fault tolerance because it allows us to carry on operations if we have some sort of physical hardware failure. It gives us redundancy because it provides a second copy or a third copy, depending on how many we decide to take. But it gives us redundancy within our data. And of course, tied to that, it gives us the ability to implement high availability. And that is to be able to bring our systems back very quickly, or perhaps almost transparently to the user and carry on operations. We can implement replication in a number of ways. So we can do that within the storage array. The very lowest level of the stack, if you like. If you look at a compute stack, that starts from the storage and goes upwards. And there are implementations in the high-end vendors from EMC, from Hitachi, like SRDF and TrueCopy. We could choose to do this at a slightly higher layer. We could do it in the hypervisor. And a good example of products that can handle the hypervisor layer would be Veeam's Backup and Replication platform. Of course, we could replicate at the host, and the host could be, in some instances, the hypervisor in the Windows scenario. An example of that could be, for instance, the StarWind platform. And then when we get above that, we start looking at replication within the application. And that could either be within the database component, and I've given Oracle Data Guard as an example here, or we could actually do replication within the application itself, and that could be a proprietary solution that the customer has built into their application, or it could be an application like Exchange, which obviously would do that replication in your behalf. So there are lots of places in which we could actually implement the replication component that we want to do in order to protect our data. So let's talk about array-based replication, because that's the subject of what we're here to talk about today. So array-based replication talks about the array itself copying the data. And we have a primary array in this instance, if you can see on the presentation slide, and we're copying that data to a secondary array. Effectively, the primary host writes to the primary array, and the array does the hard work of copying that data to the second device. The data is then available for the secondary host to read it should a disaster occur. And we'll talk about the different types of replication on the next slide. We'll come back to this slide in a moment because it does give us an idea of the actual write I/O process, and we can talk about how things work in terms of the different replication types. So what do we mean by replication types? Well, there are 3 main types of replication that we see in array-based replication today. First of all, we see the synchronous type of replication. And by synchronous, what we mean is every I/O that gets written to the primary array has to be written to the secondary array and acknowledged back before that acknowledgement can be given to the host. If we look at our previous slide and we just look at the flow of how that data goes across the devices you can see there, what we mean is that the primary host does its write I/O, it goes to the primary array, it's replicated by the array to the secondary device, and then The secondary device confirms that it's there, tells the primary array that it's been done, and then the primary array confirms that I/O to the host. So as you can imagine, you're actually going across 2 bits of network there in order to achieve every I/O. The second type of replication is asynchronous. And this is where we do the same level of write I/O, and all of the writes have to be applied in order on the secondary array to make sure we have data consistency. But the time in which that occurs is not instant. It's not tied to the requirement to confirm that I/O back to the host. So what we see is that the secondary array catches up at some stage, and it could be maybe milliseconds or seconds behind the primary array in terms of its accuracy of data. Now, if you're a large organization like a bank, I'm sure you'd probably be very happy if your data was synchronously replicated. But obviously, asynchronous has its place, and the key big piece about those 2 types of technology replication is that every I/O that you see has to be written to the remote site in order. And that takes us on to the third type of replication that we're going to discuss today, and that is point-in-time replication. Now, there are maybe different words you could use to describe this, but when we say point-in-time replication, we're referring to the idea of where we batch up the I/O writes and we apply them to the remote site periodically. And that period is usually based on some sort of time interval, perhaps, for instance, say every 15 minutes or every hour or whatever we choose to do. The difference between that and the previous one is, of course, we haven't replicated every individual update onto that remote site. So if we had an outage at any point, our data could be up to 15 minutes out, depending on what the period is at which we write that snapshot. The difference between this technique and the other 2 techniques is that we're batching up all of the I/O. So if we have a lot of I/O, the only data we're shipping to the remote site are the changes that are comprised in the snapshot. And that makes it good for low bandwidth connections. So let's discuss those different types of replication and discuss them in more detail relating to the sort of features that might be relevant to delivering a replication service. The first one is recovery point objective. And recovery point objective is a definition that says how far out of date would we want our data to be if an incident occurred, if a failure occurred in the system. Now, ideally, if money was no object, then I guess we would say we wouldn't want any loss of data to exist. And that's what synchronous gives us. Now, of course, there's a trade-off for that in terms of cost, because it's both expensive in terms of the license. It tends to be an expensive licensed product, but also because we're replicating every single I/O, the network traffic is quite significant, and therefore we need to have an expensive network to make that work. The other trade-off with that, of course, is that we have an issue with latency. And the further we put away the arrays, that we separate the arrays from each other, the greater the distance, the longer the latency is to get that right to the remote array and back again before we confirm it to the host. So synchronous replication is very latency sensitive, and that can have a direct effect on how far you can place your arrays apart. So if we look at asynchronous, then clearly that isn't quite as close to RPO as 0 as synchronous is. It could be milliseconds or seconds out. But we still have to have a reasonably good network in terms of its throughput, because we'll potentially be replicating every single transaction. Latency is not as much of an issue because we can stack data on the line and we can have a lot of data in transit. So it's not as much of an issue with latency. It's more a bandwidth issue with asynchronous. But of course, we still have to put that network in place, and there's still a license cost to be achieved with that. And that finally takes us on to the point-in-time method of replication. With this, of course, the RPO maybe even longer than that. It could be minutes later or even an hour later, depending on how often we take those snapshots. However, we need a lot less bandwidth, because what we're pushing is only the changes in data that have been accumulated up over that period. And the way to think of that is to imagine if we were doing a lot of updates to a very small subset of our data, all of those updates would be consolidated together, and it would only be the last update that we passed over to the remote site. So potentially, point-in-time replication can be much more efficient in terms of its actual bandwidth than it needs. But of course, you haven't got that granularity in seeing every single update that went on. Of course, that makes it less expensive, and latency is not as much of an issue because it's just literally the time it takes to get that snapshot across to the remote site. So as you can see, there are trade-offs with each of the different types of replication, and obviously that's related to the service you want to apply for your customers. So, well, if we look at array-based replication, and we've talked about the different types, are there any issues that relate to that? Well, of course there are. So, first of all, let's talk about synchronous replication. Great for getting data to the remote site. Great if you're a bank that needs to make sure that every single transaction that was ever done is committed on more than one device in case you have a hardware outage. Not so good if you have data corruption or some sort of software bug, because any change to that primary data will be replicated to the remote site instantly. And that's where point-in-time replication can be quite useful, because you've got a period or an interval by which you can actually stop that getting to the other side, or perhaps if you're storing up those snapshots, you can actually replay them on the remote site and you can back out any software corruption or bug that may have occurred. Array-based replication tends to be based on the LUN, and by LUN, when we say LUN, we mean volume, and that's the smallest object that the array tends to replicate in today's environments. And the reason for that, of course, was we did have a time before virtualization when the LUN was the whole was the subset of the application. We may have a host which had 4 or 5 LUNs defined to it, or even just one. So, of course, replicating at the LUN level was perfectly acceptable. With virtual environments, we see a change, of course, now, and LUNs can be or volumes can be very big. We could have a 2 terabyte volume, and the LUN is now a superset of our virtual machines, and the LUN potentially encompasses many virtual machines. The problem with that, of course, is that the LUN now, if we replicate that to the remote site, or we went to the remote site for our replication, now encompasses every single virtual machine on that volume. And we might not want to put them all together and replicate them to the remote site at the same time. Typically, array-based solutions have no replay capability. They tend to be designed literally to get the data to the remote site and store it on the remote data, on the remote system in order. Now, I would say that, of course, that tends to apply to block-level devices. Some of the file-based arrays obviously are not quite the same because they do store up the snapshots that they keep. But in general, synchronous and asynchronous solutions tend to have no replay capability at the remote site. Our replication copies tend to be crash consistent, and by that we mean they're not application aware. So when we go to the remote site to use that copy, it looks like the system's crashed, and it looks like we've just pulled the power off the system. And when we reboot, of course, we might be very lucky and everything might come back quite cleanly. We, of course, may not be so lucky, and we may have to go through some sort of either file system recovery or database recovery to bring that application back. Replication protocols are proprietary now. Not surprisingly, in a lot of the legacy older hardware solutions, replication was built into the architecture of the underlying infrastructure in the way that the data was laid out on the disk. What that means is, replicating from one device to another device, you need a target device that actually matches that. So if you're putting into in an expensive array, you're replicating to an expensive array. So it costs you a lot of money to build that second copy because you can't replicate, for instance, to say cheaper storage. Now, there are ways to get around that, and there are solutions that allow you to maybe use a third-party device to do your replication, which could get around that. But in general, replication protocols are proprietary. And what that certainly means is you're not going to be replicating to something like the cloud, as an example. And finally, on this slide, typically these solutions don't provide tools to see inside volumes or inside LUNs. and understand the idea of what a virtual machine is. So if you want to do recovery of that data, you're recovering the entire volume. And that potentially could be quite large when you want to actually mount that somewhere else. You could be mounting an awful lot of data to another server that you don't actually want to mount there. Okay, so let's compare that and let's talk about hypervisor-based or VM-based replication. Now look, clearly this is very different. We have a much better level of granularity here. So rather than replicating an entire volume or LUN, we can now replicate at the virtual machine level. And that's much more focused in terms of the actual service we're offering, which is typically a virtual machine or one or more virtual machines that comprise an application. We don't need to group those VMs on a LUN. We can keep the performance of the storage separate from the need to do the replication. VM-based replication, as we just said, tends to be applied at a VM level, and that means we can be more granular with our service. So if we have groups of VMs that we need to replicate with highly synchronous replication, we can do that. If there are others like development environments where point-in-time replication is good enough, then we can do that too. And it allows us to apply a service level much more accurately to our application. A lot of the VM-based replication solutions are application-aware, so they use guest plugins like BSS and so on, which can synchronize and allow us to make sure that our data is much more consistent when we take that copy. And that's obviously a big bonus if you've got an application that's quite complex and you still need to be able to secure that entire VM. And one other thing we should bear in mind, of course, is that these solutions tend to have a lot more optimization in them. The older solutions that are based on the array tend not to deduplicate or compress that data before they replicate it, whereas the solutions that are more VM and hypervisor aware or host aware have the ability to do things like deduplication and compression of data before they're replicated to the remote site. And doing deduplication can potentially save you an awful lot of bandwidth, depending on the type of data that you have. If we go back to the subject of storage devices, obviously we said previously that we would have to replicate to a device of the same type. Well, that's not the case with our hypervisor-based solutions. We could actually have a different storage device at the remote site, which could be cheaper, or perhaps could give us a different service level. For whatever reason, we can actually make it different, and that potentially can save money for the end user. So some of these services we have to bear in mind, though, do need a dedicated proxy VM to do the replication process. So it's not all good. There's a little bit of overhead there that you have to remember. However, because of the nature of the way that they're doing that replication, a lot of these solutions do actually give you a point-in-time recovery point, and you can restore from any of those point-in-time recovery positions, which is a lot more flexible than a simple replication solution. So what about volume-based replication? Well, when we talk about array-based, we're sort of saying that's like volume-based replication, but in actual fact, it's hardware-focused. And volume-based is another way of doing things that's slightly different, but is very similar to the array method. However, it has a lot of the advantages of VM-based replication. So we can replicate at the virtualization layer. A good example of that would be the technology from StarWind. And of course, we can create lots of logical volumes rather than have physical volumes on disk. And that means we can choose how to lay out our data more effectively. We can still replicate between disparate array types, so we've still got that flexibility to have a different type of technology at the remote site. And of course, because we're looking at the data at a volume level, we can do things like deduplication and compression before we replicate that data, so we have the benefit of those facilities too. We should remember, of course, that with this technology, we could still also replicate to cloud environments, which potentially could be beneficial in the future to be able to replicate a VM into the cloud and then reboot it from there as a disaster recovery scenario, or even, if we're not just talking replication to DR, could actually be a migration process. And of course, like the previous type of replication we just talked about, we can also do point-in-time replicas and keep those as historical restore points. So, and this is the last slide from me before we move over to Matt. Let's just compare the two and say, where would we use one and where would we use the other? Well, volume-based replication potentially is good for replicating application-based data on dedicated LUNs, or where we can easily separate the operating system and application data. So, for instance, where we deliberately add extra volumes and we know that the data is purely just the most volumes, and we move it to the remote site and we know we could mount those up, then that's one good way of doing that. These solutions are very, very good for hardware abstraction, especially going up to the cloud, as we've just discussed. And of course, they take advantage of optimization techniques, which is very useful for optimizing our bandwidth. So let's compare that to VM-based replication. Those solutions are great for replicating the whole VM. And as an example, that might be a scenario where it's not easy to separate the application and the operating system. So think of, say, an email system or a SharePoint environment that's been deployed on a single server or a couple of servers where separating the data is quite difficult. Replicating the whole VM might be the right solution there. We still have the benefit of being able to take advantage of hardware abstraction replicating into the cloud, which is good. And of course, these solutions give us that granular level of replication. So we talk about the VM as the object still, and that's much more a service-based sort of approach in terms of replication. The other thing, of course, is like the volume-based replication, we still get the benefit of being able to use features like deduplication and compression. So we still get those optimization features. And in reality, both solutions give us a lot of very similar commonality, but perhaps we differentiate it purely by the type of data we're looking to replicate and the type of systems. So I think I've gone through that quite quickly. Hopefully that should all be quite straightforward. And I'm just going to hand over to Matt now, who's going to talk us through Veeam's approach to this and how it applies. And then we can see how what we've talked about is actually implemented in their technology. Matt, I'll hand over to you and I'll move you to the next slide.
Excellent. Thanks so much, Chris. Lots of great, valuable information. Hello, everyone. My name is Matt Price. I'm one of the systems engineers here with Veeam Software. So thank you very much for giving me the opportunity to run through Veeam's replication technology. Before we dive into the specific replication segment of our software, I just want to give you guys a real brief overview of what Veeam is really all about for those of you who may not have heard of us before or maybe haven't seen our software in action. So we do provide both backup and replication technology, and certainly if you guys needed the backup side, we can dive into that at a later time. But our software has been purposely designed exclusively for virtual infrastructures. So everything that we provide is going to be an agentless solution across the board, and this is also applicable for replication technology. And we do give you the two-in-one solution of both backing up your environment with very, very short recovery time objectives down to the minutes, as well as replication in a single software solution. Now, let's focus on what Veeam provides when we look at the topic for today, which is protecting your environment with data replication. So, based on what Chris was speaking about earlier with the different types of replication, when you look at Veeam, we're going to be a point-in-time replication solution. Now, all of our replication is going to be job-based, which means you're going to create a job very similar to a backup job where you're going to be selecting individual virtual machines that you would like to replicate. Now, let's define our definition of replication, right, because there are a few different definitions. The way that we replicate data is by creating a full-blown virtual machine at a remote environment, either VMware or Hyper-V. Those are the two platforms that we do provide support for. Now, this VM is going to be fully registered within inventory. It will live on production storage. You'll see it in either your vSphere client or your virtual machine manager. It will simply be powered off and dormant. So it's sitting there waiting on a disaster to occur, fiber cuts, power outages, or even worse, things like natural disasters. So it provides you that high availability with easy failover and failback, which we'll talk about. Okay, so it's not deduped, it's not compressed, it's fully hydrated. Now, when you create these jobs, you can select any number of objects to include. You can either do manually choosing individual servers. You can use container approaches like maybe a vSphere folder or a data store, for an example, as your source. Whenever we do replicate, Chris mentioned it earlier, we do have transactional consistency built in because Veeam does have a tie-in with Microsoft VSS technology. So whenever we create the snapshot on the source side, that data that is going to be replicated has been properly quiesced, all of the memory flushed and consolidated to disk. So whatever we do replicate is going to be transactionally consistent, which is certainly very important when you talk about those highly transactional workloads, Exchange, SQL, SharePoint, things of the like. Okay. Now, we do compress and deduplicate that traffic in flight, and we can target any hardware. So we're agnostic when you speak about hardware. Now keep in mind, this hardware still does have to be compatible with the hypervisor. So we can't do things like go to VMware over to Hyper-V infrastructures. So basically you have to look at your hardware as being compatible at the VMware or the Hyper-V level, but Veeam doesn't have any additional requirements. So it gives you a wide range of flexibility on where your replication target is. Now, we're only going to be replicating change blocks only. Now, Veeam can actually leverage VMware's change block tracking, which is built in. And for Hyper-V infrastructures, Veeam actually developed our own change block tracking mechanism. So regardless if you're a VMware or a Hyper-V environment, whenever we run these job-based replication schedules, it's only going to be delta changes. Now, as far as job frequencies, you can replicate anywhere from once a day, twice a day, once a week. You could replicate every 90 minutes. You could get down into, let's say, every 2 to 3 hours. You can get down and also set that job to run in a continuous fashion. Now, keep in mind, I mentioned earlier, we're point in time. We are not synchronous replication, so that continuous option is simply a looping job. Okay, so basically as soon as our replication pushes over the change blocks, consolidates the source side snapshot, we simply start that process over again. Now, for those of you who have, maybe the bandwidth isn't quite what you would like it to be between your two locations, we provide a number of solutions to help with that. Number one, we give you replica seeding capabilities. So you can simply take a backup locally of whatever virtual machines that you need to replicate. You'll be taking advantage of source-side dedupe and compression, maybe saving that data to an external drive, and then you can either drive it or ship it over and use those backups to create your replicas. Now, another option is, again, we're going to be deduping and compressing data in flight, but we also offer WAN acceleration. So if you're severely limited with bandwidth, you've got a high latency link, and you simply just don't have the throughput to send over the amount of change you're taking, we can help with that by leveraging our own WAN acceleration technology. And essentially the way that concept works with Veeam is we're going to use a source-side digests and a target-side global cache pool. And if we detect any duplicate data blocks that already exist at that target-side cache, we can simply remove those from the initial data transmission. And you may be asking yourself, well, how do you find duplicate data if you're already deduping? And that's because when we dedupe on the source side, it's going to be fixed block, and it's job-based deduplication. So it depends on how you group your VMs together in a replication job. Whereas the WAN accelerator is variable block global deduplication. So you will be able to detect duplicate data blocks, reducing the amount of data that you have to transport across that wire. Now, some of the new capabilities we've just released in version 8 involve failover plans and one-click planned failover, which are not the same thing. A failover plan is the ability to create a group of VMs, maybe a phase 1 and phase 2 scheme, where you fail over your more mission-critical servers first, maybe your authentication servers, things like this, and then progress to phase 2. Now, the failover plan is also a way for you to specify the priority at which those VMs get powered on, any relevant delays that should be applied in between boot cycles, as well as the ability to run pre- and post-failover scripts if necessary. And the one-click plan failover is a perfect solution for a data center migration, because what that will do is allow you, with literally one click, we will shut down the source side VM, rerun the replication job one last time to get all of the change data, then fail over to the target side. So that way you can do that data center migration, that planned failover, with zero data loss. Now, what about readiness testing? What about, the assurance of knowing that DR site is ready to go? Veeam also has a technology called Sure Replica. Now, what Sure Replica is all about is the ability to start your replicated VMs that we have created inside an isolated environment, we call it our virtual lab, at your DR or your colo site. And the point here is we want to verify that those VMs are bootable. There's no hidden issues like registry or driver corruption. You're not going to get a blue screen when you try to boot the machine. And once we get it running, we can then do heartbeat checks. We can do ping testing to verify networking, even allow you to run custom script verifications to assure that in-guest services have started properly on those replica VMs. Now, when we're done with this testing, we're going to power down the VM and email you an audit trail report with date and timestamps of everything that we verified to ensure recoverability. Now, that entire process can be automated. You can have that set up on a schedule that's different from the replication schedule, maybe once a week or once a night, something like this, maybe once a month, or you can actually link it to the replication job so we verify as soon as we push over the delta change. Now, another really nice feature around Sure Replica is you can also use that isolated environment as a sandbox. So a lot of times when you look at disaster recovery locations, unless you're in a disaster event, those resources are simply sitting there dormant, collecting dust, waiting on a failover to occur. So Veeam enables you, simply by having our replicas, to use those resources to provide you a sandbox on demand. So very important capability, just another way that you can leverage your replicas when you're not in a disaster situation. Now, what about networking? That's another really nice piece to Veeam. We can automatically inject new IP data right into the registry of any Windows-based virtual machine automatically during the failover. And then for any virtual machine, regardless of operating system, we can remap the VNICs and reconnect them to a different virtual network so that if your DR site is on a different subnet, runs on a different IP space or scheme, we can handle that automatically. Now, another point that Chris mentioned is with the VM-based replication, also we can give you a little bit of extra padding per se, or a buffer zone if you want to look at it this way, as opposed to synchronous replication. Once everything is replicated, it's done and it's instant. So if you catch something at the source side, like a virus or malware, it's too late at that point because it's already been replicated. With Veeam replication in a VMware environment, we can give you 28 different restore points per replicated virtual machine. Now keep in mind, we're not talking about backups, so those restore points are simply stored as native snapshots within the hypervisor. So if you needed to fail over to a previous point in time, you've got 28 previous points you could leverage, and it's an optional thing. In a Hyper-V environment, that's actually 47 available restore points. And these are all hypervisor limitations, not Veeam. So those are the amount of checkpoints we can keep on disk per VM to give you an extra padding and buffer zone if you want to look at it that way. So that's Veeam replication in a nutshell, guys. Obviously, there's a lot more to our software when we look at, the simplicity of the failover and failback. For an example, we have Delta Sync failback technology as well. So if it's a survivable event that triggers a failover relevant, like a power outage, you have to fail over to your DR site for a few hours, power gets restored. As long as those source VMs come back online, we're simply failing back modified data blocks only. We don't have to resync everything across the wire, so especially for those environments with low bandwidth connections, that's a huge feature because we're going to reduce the amount of data that has to flow back across the circuit. Now, if you guys are interested in digging a little bit deeper into Veeam, we conduct daily webinars that you can register for directly at veeam.com, where we can dive into the backup side, the replication side, and we also have monitoring solutions as well. So please check those out at veeam.com. So that's all from me. I'm going to pitch it over to you, Max, and thank you very much for the opportunity and the time today.
Hey, hi, Matt. Thanks for the great presentation of your backup solution. And let me just start with my part of the slides. So as Chris already mentioned, I'm StarWind Virtual SAN Product Manager, and we are a software-defined storage company, one of the first guys who released a hyper-converged storage scenario. It was back in 2011, so far before the industry even started to use that term, and it became a meme. And we also jumped into the replication world because that was a huge demand from our customers. They wanted to have one vendor doing both their primary site storage and also replicate their data offsite. So since we are a VM-centric storage company, we were also trying to think a lot about how we replicate data and what data do we replicate. So what is the actual benefit we need to deliver to our target audience to make sure it is convenient for them, and we just don't sell, let's say, a database backup to people who use virtualization only and all the features we're trying to provide are completely irrelevant. No, we'll try to be smarter than that. So how the array level replication changes when we go with software-defined storage. So as Chris previously mentioned, if you have a dedicated array, it may have some constraints and limitations in terms of how it handles the data, what it replicates, and what's the state of the replica if you restore during a disaster recovery procedure. Now, with StarWind, we try to address as many of those problems as we can. So while Veeam is handling really granular VM level replication, so you can make sure that for those virtual machines where you require RTO and RPO for specific applications, you can use Veeam. And if you want general use replication, which is also VM-centric, in this case, StarWind can definitely address that and lower your RPO and RTO for the total recovery. So first thing mentioned was the human factor, which is both viruses, tossed cables, drives taken out of the enclosure and stuff like that. Any stupid thing which can happen will happen. That's a little rephrased Murphy's Law, but it really applies to the IT world. So we are adding our ways to protect the data in your disaster recovery location from all these factors. That's why we use snapshot-based replication. So we do a base replica, and then we just replicate snapshots of the primary site to the replication site. So in the event of a disaster recovery, or if anything happens, you always have at least one more way to take a step back and get to the most recent healthy state of your data. And not only that, but you can have up to 255 points to restore to, and even if you caught a virus at some point, you can always jump back and data from there. Now, that does not necessarily require you to deploy the virtual machines on the disaster recovery side. You can simply use that DR location as your snapshot repository. So a lot of scenarios assume that StarWind is used within one location, but there is a slow storage which stores snapshots and stores an let's say offline replica of your data. So it's an active passive replication which is not only for the internet but for local sites as well. Now, The next concern about array-level replication is that it is crash consistent. With StarWind Virtual SAN, we tightly integrate with the hypervisor. So every time we take snapshot, we make sure that we sign a contract with the hypervisor and say, okay, guys, we're doing a consistent backup here. Yeah, indeed, we're doing a consistent backup here. So every time you restore, you actually restore to a granular point in time where your virtual machines will be able to say, hello, we're launching our applications. There is no need to do check disk and stuff like that. That is another good thing which makes your disaster recovery easy, because people are under really huge amounts of stress in this type of situation, so we try to make their lives easier and make the solution as simple as possible. So even in a stressful situation, the solution is as simple as AK. You just take it, use it, and you don't have to read the manual for 2 hours before you can restore your virtual machines. Now, next thing we try to change about replication is to minimize the WAN link utilization, because a lot of the solutions just replicate all the data you have offsite. That may be good, but not in a virtualization scenario. It's a lot of information, and there are really a lot of ways to make that data optimized before you send it offsite. So if you look at the diagram, our virtualization layer sends the raw data where on the StarWind level it gets deduplicated inline, and only then we replicate that data offsite. So all those snapshots are not only consistent but also dehydrated, so they do not consume that much space, and the WAN link is used much more effectively. And on the other hand, it also allows us to minimize our replication window, so we can have more granularity points replicated to the offsite location within the same amount of time. And if this is not sufficient, this also works with any industry standard WAN optimization tools, which can increase the effectiveness of your WAN link even further. And one last thing I wanted to mention regarding VM-centric replication solution on the array level is the fact that we are able to back up the virtual machine data not only to a DR location, which is on premise, it's a data center, or just a server you have at home, depending on the business type you run. We can replicate basically anywhere. StarWind virtual machine can be deployed even within public or private clouds, and the replication can go there. So there is absolutely no need to host a full backup server somewhere. It can be just a virtual machine, let's say in your partner company data center, and you replicate to each other's locations for security. It can be anywhere across the border. It can be across the ocean. So essentially, there is no need to worry about where to put your backups. We can handle the backups which are replicated in multiple locations. And keep in mind that with this solution, you don't need to pull all your data back from the cloud in order to restore your system. You still have those snapshots you can redeploy, so StarWind can get the snapshots back to the primary site and get your primary site up and running. So if you have a minor outage, there is no need to replicate all the data back. With that, I'd like to hand everything over to Chris, and thank you for joining our today's event and attending the presentation. Stay tuned. We'll have the Q&A session shortly, and Chris will get us some questions.
Yeah, definitely. Thank you so much, Max, and the guys, Matt and Chris. Thank you so much, the other Chris. Thank you so much for giving your presentations today, guys. Much appreciated. So for those of you in the audience, if you had a question for the guys, please feel free to enter your question now via the Ask a Question box. On the left side of your console, if you have a question, please just type it in there, and it'll be sent off to me, and I'll ask the guys your question. The first question we had is, Max, is your product compatible with Zen Server?
Yes, our product is compatible with Zen Server, and there are two ways to install StarWind with Zen Server. We have several clients who use older Zen Server installations and actually run StarWind as a virtual machine inside Zen Server, but majority of people use StarWind as an external SAN and use it with Zen Server. Now, the only thing which we constantly have with Citrix is that they do not really follow all these SCSI standards. So a lot of times when we try to change the multipathing and iSCSI stack within Citrix so it works properly with StarWind, it appears that not all the changes get reflected in the way they interoperate. So make sure that you've got a solid back from Citrix or from your consulting company which will assist you configuring the solution.
I got a question here for you, Max. Somebody was asking, sorry, I lost the question here. Let me find it real quick. Sorry about that, audience. If you do have a question in the meantime, please feel free to enter it in the Ask a Question box on your console. We'll get to as many as we can before the webcast ends today. The question was, does StarWind support clustered share volumes and Hyper-V clusters?
Yes, indeed. StarWind does support cluster shared volumes. I mean, StarWind essentially is a block-level storage, so we will support whatever the client puts on top of that block-level storage. That can be an SMB share, that can be a cluster shared volume, that can be a data store with a bunch of VMDK files. All that is supported by StarWind automatically because it's a universal solution for storage.
This question here is for Matt from Veeam. This question is this person saying, I'm running Veeam now to USB storage. He would like to back up to a remote location encrypted over the internet. Is there a way to do this, i.e. with no VPN?
So actually there is. We just came out in version 8. Not only did we add encryption that can be added with AES 256-bit end-to-end. That's new in version 8. And we also came out with a feature called Veeam Cloud Connect. And what Cloud Connect enables you to do is leverage one of our managed service providers as your remote cloud target. And Veeam virtualizes all of our traffic across a single port. And that does enable you to get your Veeam backups directly to one of our MSP provider data centers without needing, VPNs or sophisticated firewall settings. So yes, we do have that now in version 8.
Are the backups, this question was from Matt too as a follow-up, are the backups encrypted? Somebody especially was curious if they were backing up to tape. Is that encrypted?
Yes, now in version 8 they can be, and you can actually specify if you want just the backups going to tape to be encrypted and the ones landing the disk can be decrypted. So there's definitely flexibility there now in version 8.
All right, excellent. Thank you so much. Well, we've run through the questions, guys. If you had a question and you thought of it, after the presentation is over, you could just email me over here at Redmond Magazine, and I believe Tracy Cook, an associate of mine, her email is on the console as well. So you can email us your questions if you didn't get them in now for the guys, but please feel free to do so. But thank you, guys, for joining us for today's webcast. Really appreciate it. Chris and Max and Matt, thank you so much for taking your time out today. Really appreciate you doing so. Today's webcast, Protecting Virtual Machines Using Data Replication, has been sponsored by StarWind Software and brought to you by Redmond Magazine and redmondmag.com. Thank you all for attending today's program. We hope you have a great rest of your day, everybody, and happy holidays. Take care. Bye-bye.
Bye-bye.